Good evening, all of you. Hello, welcome to all in my class. Today we'll discuss the uniform motions. Yes, already we have started the motion chapters, and you know what is the motions and what is rest. You know that also whenever the object or any, okay, even human beings, it covers some distance or displacement, okay, with respect to time. We say that is in motion, okay. But the object are in, okay, at the same positions. The time interval is going on. There is no change in their, okay, distance or displacement, and that we say that the object are in the same position, so it is in rest. Okay, we have also discussed about the uh, distance. What is distance? It is the actual path covered. You know, yes, it is the actual path covered by object from, okay, one point to another, that may be the straight or curve. Is it clear? But you know that whenever the object changes, sometimes what happens, the object covers in uniform motions, and that may be the non-uniform motions. Okay, so today I am going to discuss about that we have the uniform motion. Uniform motion means, what is the uniform motions? Uniform motion means if an object covers equal distance in equal interval of times. Okay, if the distance cover equal distance or displacement in equal interval of times, and that we can say this is the, okay, uniform motions. And in the uniform motions, what you will see, the graph, if you will plot, okay, that will be in the states. Okay, so we can, okay, write this once. Uniform motions means an object, that you can write here, an object are said to be in uniform motion if it covers equal distance equal distance in distance or displacement, also you can take displacement in equal interval equal interval of time. Okay, means I have written an object are said to be in uniform motion if it covers equal distance or displacement in equal interval of time. Suppose that one example I am taking here, the distance, okay, or time you can take here. Suppose that time, it is, its unit is in seconds, and now I have taken here the distance. Okay, distance, you know that what is the unit of distance? Maybe SI unit is the meters. Okay, and bigger units you can take the kilometers, no problem. So smaller in CGS you can take the centimeter also. But I have taken one example. Suppose that an object is moving, okay, uniformly, and when the times, okay, when times, suppose that is 0, on that times the object are in the rest, that is, okay, there is no distance or displacement, it is in the same position. But consider, suppose that after 5 seconds the object covers the 10 meters, and after 10, suppose that it is 20, and 15 when the time is 15 seconds, and their distance is 30. And also you can take next, suppose that here is a 20 and this is the 40. So I have taken here the times and the distance, and that we can plot in a graph. Okay, you know that suppose that you have, this is the x-axis and this is the y-axis and this is called the origin. Can we take like that? Okay, very good. Now you we have here the time which has started from 0, 5, 10 like that, and this is called the horizontal and that is called the verticals. Okay, so you can take here times and you can write the units also and give the arrow sign, and here this is the distance. Okay, distance you can write their units and give the arrow signs. Now you see that the time starts from 0, this is the 5, that is the 10, and next 15, this is the 20 and 25 you can also take more, and yes I have taken yes 10, this is the 20, this is the 30, 40, 50 like that you can take. But if you have a scale, better you use the scale, because if you will use the scale then exactly you will take their positions. Now you students see that, so when the object starts to move, when there is a distance 0, and that time is also 0, and you know that in these points, because the x-axis and y-axis here is the initial points, so both will have the 0 and 0, x will 0 and y will 0. Here this is the x and this is the y. Okay, x equal to 0 and y equal to 0. Okay, now you see that you take the scales and join the points. Okay, what you will take here? Suppose that when time interval is 5, here 5 is here and distance is 10 meters. So these points, with the help of a scale, these you can join and you will write their coordinates also. Coordinates here is a 5 and this is the 5 and 10. Okay, next you have 10 and 20. 10 is here, 10 is here and 20 is this point. So this intersection you will write here 10 and 20. Okay, another you have 15 and 30. This is the 15 and that is the 30. You can write here 15 and 30. Okay, one more point there is given. Okay, time is 20 seconds, 20 is here. Okay, and distance here is the 40. Join these points and write their coordinates also. So 20 and 40. Okay, now you can see that here is one point, another, this is the intersection point, and here is also. So all these points with the help of your scales you can join these ones. Okay, so this is called, this straight line, that is called the, what we will call distance time graph. Okay, so you can write here distance time graph. Okay, and you can also write their coordinate points here. This is the A, that is the B, C and D. Okay students, so like that you can plot the graphs. Can you plot? I think that all you can plot the graphs wherever the object covers some distance or displacements, and according to that you can change. Is it clear? So similar, one more question I am giving you to complete itself you can do. Okay, suppose that this is one and second one. Here is the time it is in, now it is in minutes. Okay, and now I am taking here the displacement. Okay, the displacement and it is in, suppose that in centimeters. Okay, centimeters. So when the time is 0 and displacement is 0, suppose that. Okay, and here is the, suppose that 3 and suppose that here is a 5. Okay, 6, 10 and 9 and 15. Okay, this is the questions, so you will practice. Okay, so next class we will discuss like that. Okay, is it clear? So I think that you can plot similar according to these questions, all you will complete. Okay, very good. So students, you can plot the uniform motions and also non-uniform motions. How we can plot the graph if the points is given, and according to that in the x-axis and y-axis you can plot these ones. Okay student, thank you. Okay, very good.